Welcome to Audio ABET, where we explore why learning programming is akin to mastering the art of bike riding. Let's start with the obvious. Both coding and bike riding require practice. Just like how you wobbled and stumbled when you first got on a bike, coding also has its fair share of stumbling blocks. But with consistent effort and practice, you gradually become more confident and capable. Another similarity is the sense of freedom and independence that comes with mastery. When you first learn to ride a bike, it's like unlocking a whole new world of possibilities. Similarly, when you become proficient in coding, you gain the ability to create software and applications that can have a real impact on the world. But perhaps the most important parallel between coding and bike riding is the mindset required for success. Both activities demand patience, perseverance, and a willingness to embrace failure as part of the learning process. When you're learning to ride a bike, you're bound to fall down a few times, but each fall teaches you something new, whether it's how to balance better or how to avoid obstacles. Similarly, when you're coding, you'll encounter bugs and errors that may seem frustrating at first, but each mistake is an opportunity to learn and grow as a programmer. Another aspect to consider is the importance of starting small. Just as you wouldn't attempt to ride a mountain bike trail on your first day, you shouldn't dive into complex coding projects before mastering the basics. Start with simple exercises and gradually work your way up to more challenging tasks. Additionally, both coding and bike riding require a solid foundation of knowledge. Just as you need to understand how a bike works in order to ride it effectively, you need to understand the fundamentals of programming languages and algorithms to write code that performs well. Of course, there are differences between learning to code and learning to ride a bike. For one, coding is a mental activity, whereas bike riding is physical. But despite these differences, the underlying principles of learning and mastery remain the same. So whether you're strapping on a helmet or firing up your code editor, remember that the journey to mastery is often more important than the destination. Embrace the challenges, celebrate the victories, and keep pedaling forward. Absolutely. Let's expand on the parallels between learning programming and riding a bike, as well as delve deeper into the intricacies of each activity. The parallel journey, learning programming. Like riding a bike, when we think about learning new skills, certain activities come to mind as quintessential rites of passage. Among these, riding a bike stands out as a childhood milestone, while learning to code has become increasingly recognized as an essential skill in the digital age. Despite the apparent differences between these two activities, a closer examination reveals striking parallels that shed light on the nature of learning and mastery. 1. Practice makes perfect. One of the most fundamental similarities between learning to ride a bike and learning to code is the necessity of practice. Just as a novice cyclist struggles to find their balance and coordination, a beginner programmer grapples with syntax errors and debugging. In both cases, progress is gradual, achieved through repeated attempts and incremental improvements. 2. Freedom and independence. Both biking and coding offer a sense of freedom and independence. Riding a bike enables you to explore your surroundings and travel greater distances than on foot. Similarly, coding empowers you to create digital solutions to real-world problems, from simple scripts to complex software applications. Mastering these skills opens up new opportunities for self-expression and innovation. 3. Embracing failure. Failure is an inevitable part of the learning process, whether you're falling off a bike or encountering bugs in your code. However, it's how you respond to failure that ultimately determines your success. Just as a resilient cyclist gets back on their bike after a fall, a tenacious programmer learns from their mistakes and perseveres in the face of challenges. 4. Starting small. Both biking and coding require starting with the basics before tackling more advanced concepts. You wouldn't attempt a steep mountain trail without first mastering the fundamentals of cycling, just as you wouldn't dive into complex algorithms without understanding basic programming principles. Building a strong foundation is essential for long-term success in both endeavors. 5. Continuous learning. Learning to ride a bike or write code isn't a one-time event, but rather an ongoing journey of discovery. As you become more proficient, you'll encounter new challenges and opportunities for growth. Whether it's mastering advanced bike handling techniques or exploring cutting-edge programming languages, there's always something new to learn and explore. 6. Community and support. Both biking and coding benefit from being part of a larger community of enthusiasts and practitioners. Whether it's joining a cycling club or participating in online coding forums, surrounding yourself with like-minded individuals can provide valuable support, encouragement, and camaraderie. Learning from others' experiences and sharing your own can accelerate your progress and enrich your journey. 7. Adaptability and creativity. Biking and coding both require a combination of technical skill and creative thinking. Just as a cyclist must adapt to changing terrain and weather conditions, a programmer must adapt to evolving technologies and user requirements. Creativity plays a crucial role in finding innovative solutions to complex problems, whether you're designing a new bike frame or writing elegant code. 8. Overcoming challenges. Whether it's conquering a steep hill or debugging a tricky piece of code, both biking and coding present their fair share of challenges. However, overcoming these challenges builds resilience and confidence, making you a stronger and more capable individual. Each obstacle you overcome brings you one step closer to mastery and opens up new possibilities for growth. 9. The joy of mastery. Finally, both biking and coding offer the satisfaction of mastery, a deep sense of accomplishment that comes from overcoming obstacles and achieving your goals. Whether it's successfully completing a challenging bike ride or launching a successful software project, the feeling of pride and fulfillment is unmatched. Mastery isn't just about reaching a destination, it's about the journey, the ups and downs, the triumphs and setbacks, and the lessons learned along the way. In conclusion, learning programming is indeed like learning to ride a bike, a journey of discovery, growth, and self-improvement. By embracing the parallels between these two activities and applying the lessons learned from one to the other, you can accelerate your progress and unlock your full potential. Python stands out as the lingua franca of data science and machine learning. Its simplicity, readability, and vast ecosystem of libraries make it an ideal choice for beginners and experts alike. Libraries like NumPy, Pandas, and Matplotlib empower data manipulation, analysis, and visualization. Moreover, frameworks such as TensorFlow and PyTorch provide robust support for building and training machine learning models. R, while not as popular as Python overall, remains a dominant force in certain niches within data science. Its extensive collection of packages, particularly for statistics and data visualization, makes it favored among statisticians and researchers. Additionally, R's strong community support and dedicated IDEs, like RStudio, contribute to its enduring relevance. SQL, though not a traditional programming language, plays a vital role in data science. Proficiency in SQL is crucial for extracting, transforming, and querying data from relational databases, a fundamental aspect of any data-centric role. Understanding SQL enables data scientists to work seamlessly with databases and perform complex data manipulations efficiently. Beyond Python, R, and SQL, familiarity with other languages can provide additional advantages in DS and ML. For instance, Java and C++ are prevalent in production environments, especially for building scalable and high-performance machine learning systems. Knowledge of these languages can be beneficial when deploying models in real-world applications or working with large-scale datasets. JavaScript has also gained traction in recent years, particularly with the rise of web-based data visualization libraries like D3, JAs. Its versatility and compatibility with web technologies make it valuable for creating interactive data visualizations and deploying machine learning models in web applications. Ultimately, the number of languages you need to learn for data science and machine learning depends on your specific goals, interests, and the nature of the projects you undertake. While Python is undoubtedly the primary language for DS and ML, proficiency in complementary languages like R, SQL, and others can enhance your versatility and effectiveness in different contexts. In conclusion, while Python serves as the cornerstone of data science and machine learning, proficiency in additional languages such as R, SQL, Java, C++, and JavaScript can be useful. Stay tuned with Audio ABET for more.